Good morning, students. Welcome back to the class. So in the last class we went through the properties on determinants and the problems based on those properties. So altogether there were 8 properties. Among them the last two are not so significant, but while solving problems we required them. Okay, so one of the property frequently will be asked in the final examination, so just go through, practice and learn those. So in the exercise, in the worked example, I said I will come back to the worked examples later on. So first let us concentrate on the exercise part. So in the exercise we have done with a few problems already. Okay, now let us continue with the remaining problems in the exercise. So let me just check the next problem. Okay, the next problem was, see, it was the first heading, show by using the properties not to expand and get the answer. That part is done. So what they're telling is, by using properties of determinant, show the following. So altogether there are 7 problems. In that submains are also there. So let us try one by one. So among that, the first one, so the first problem is determinant 1, 1, 1, a, b, c, a square, b square, c square is equal to a minus b multiplied by b minus c multiplied by c minus a. So all these are show the problem. So let us start with the left side and try to get the right side. So I will start with the LHS of the problem. So the LHS is 1, 1, 1, a, b, c, a square, b square, c square. Okay, look at students. See, the first type of working in this, just always just see if there is 1, 1, 1 actually. See, in the first main, yes, 1, 1, 1 is given by them actually. In the second main also, see, in most of the problems they will not provide 1, 1, 1. If it's 1, 1, 1, the procedure is, see, you notice there are 3 ones here. See, this is a leading element of R1. That's a leading element of R2, and this is a leading element of R3. There are 3 ones. Any one will be retained. The other 2 ones will be made as 0. This is a procedure. This procedure will be applied to most of the problems of this topic. Remember. Fine. Okay. So what I will do here, I want to make these 2 elements as zeros. So I will round off the elements which I want to make it as 0. You will be asking, sir, expand it and get it, sir. Yes, we can get it, but the heading is what? Using properties of determinants. Solve it or prove that. Correct, right? Okay. So what I will do here, for R2 element, see, my simple calculation is to make this element 0, right? What if I subtract these 2? Or what if I subtract these 2? In any form it is fine. Okay, students? So what I do here, I will write down R2 as R2 minus R1. You will be wondering, sir, which property is applied? Property number 6. The actual way of writing this is R2 elements will be written as R2 elements plus minus 1 multiplied by R1 elements. If in a determinant, if you are multiplying the elements of any row or column by a scalar and add it to any other row or column, the value remains to be same. Using that concept, we are applying this. So instead of writing this, I will write this thing directly. Now for R3, there are 2 options. Either I can go for these 2 as, okay, to get 0, or I can subtract these 2 to get off 0. So my option for R3, let me go with R2. I want to go with R2, that's it. Now, see, the operation is applied in row wise. You write the elements in row wise also. First row, no change. So 1, A square. Now let's come to the second row. Each element of second row is written as second row elements minus first row element, correct? Now 1 minus 1, 0, b minus a, and the next one b square minus a square. Okay, students? Now the next R3. Come to R3. R3 is written as R3 minus R2, correct? Now, so 1 minus 1, 0, c minus b, write down as it is. The next element c square minus b square. With R1 I have an option actually to go with R1 also, or to go with R2 also. I selected R3 with respect to R2. Okay, fine. Now let's see what happens. Okay, students. Now tell me, what is the formula of b square minus a square? Formula of b square minus a square is b minus a multiplied by b plus a. I will not show that inside here. I'm just showing what is the expansion. Similarly, what's the expansion of c square minus b square? C minus b multiplied by c plus b. That means, see, this 0 can be written as 0 multiplied by b minus a and b minus a, and here also b minus a is common. So what I do here, I'm going to take b minus a common from R2 and c minus b common from R3. Fine. To get this common element and to make the expansion simple, we are doing this thing actually. So this 0, so you will be wondering, sir, it is 0. Where is this actually? B and b minus a is present. 0 can be written as 0 multiplied by b minus a. Still it's going to be 0 only. So that means b minus a is common in all the 3 elements. So let me keep that outside. Okay. And once again c minus b is common from here. And after taking common, let's write the remaining. So 1 a square. 0 is 0 itself. B minus a is taken outside. So 1 in place of that. See here, b minus a is taken outside. The remaining element is b plus a. Okay, now come to the next 0, 1. C minus b is taken out. From the c minus b is taken out, the remaining element is, the rest is expansion of this determinant. The first type of problem, okay, where 1, 1, 1 is present in a row or in a column. This is the first type to recognize. There are many types. I will just tell you when the time comes. So let us solve this one. So on solving this, now first element b minus a as it is. The next one c minus b. Now look here. Open the bracket and then expand. First element is 1, 1. How do we expand? Leave the column and row in which 1 is present and expand these 4. Correct, right? So 1 multiplied by c plus b minus b plus a multiplied by 1 is b plus a. So there is a minus sign. So put the bracket. Now let's go for the next element. What's the next element? Minus a, because of the signs. Correct, no? So the next element is a. Open the bracket. 0 multiplied by c plus b, 0. b plus a multiplied by 0, 0. The last element is a square. 0 multiplied by 1, 0. 1 multiplied by 0, 0. The expansion is over. See, the advantage of this making 2 ones as 0 is this, students. 2 elements will directly become 0. No need to expand. That means no need to expand these 2. You can just leave it as it is. So let us write down the remaining elements here now. So it is b minus a multiplied by c minus b. And if I simplify this, this is c plus b minus a. This also get cancels. I'm going to erase the thing here. Okay, now the remaining elements, b minus a multiplied by c minus b multiplied by c minus a. Clear? But this is my required arrangement, right? So I just need to adjust to get this last thing. See, I want a minus b, but here it is b minus a. So take minus common, minus of a minus b. Minus is taken common. My second element should be b minus c, but here it is c minus b. So once again minus is taken common. So this is b minus c. The last element is c minus a. Here also c minus a. Nothing to change. Write down c minus a as it is. Minus multiplied by minus plus. So a minus b multiplied by b minus c multiplied by c minus a. Yes, students? Excuse me. Okay, so that's how it should be done. So using properties of determinants, we are solving this. So it should be done like this. Don't mind, there is summer and there is a lot of heat here, so I cannot switch on the fan because the fan sound will disturb the things here. Okay, fine. Okay, now the first column is done. So what do you notice in this column? 1, 1, 1. They are the leading elements of each row. Okay, then an operation was applied. See, the concept is this: out of 3 ones. It's not that you have to make these 2 as 0 and retain this. No, you retain this and make these 2 as zeros. No problem. Or retain this, make these 2 as 0. No problem. So out of 3 ones, 2 ones has to be made 0. That is the concept. Once you made it 0, of course there is a common element present. Take it outside, expand. Just 3 steps. So 3 ones will be there. We will make 2 ones as 0, take common and expand. This is the procedure. So let me just take the next one similar to this. So the problem is first line only, second column 1 1 1 A B C, A cube B cube C cube, and this should be A minus B multiplied by B minus C multiplied by C minus A, and the last one should be A plus B plus C. So this is what I require, just similar to the previous column. Okay, so use the properties and get this. So I will just remove the right side, just remember the right side since I want to save some space. So let me start with LHS directly. Now look here, this time these 3 ones are the leading elements of C1, C2, C3. They are the leading elements of C1, C2, C3. Previous one, 1, 1, 1. They are the leading elements of R1, R2, R3. Leading, that means the first element. That is what the meaning. Okay. Now that means this are the leading elements of rows. So the rows operation will apply. This time the 1, 1, 1 are present as the leading elements of column. So column operation should be applied. That is the way to decide the operation. Clear? Okay. Now that means I should apply. I will retain this one. I want to make these 2 as 0. So let me round off these 2. So an operation for C2, C2 minus C1. And operation for C3, C3 minus C2. You can go with C1 also. So let's continue. So 1 A cube, no change as it is. 1 minus 1, 0. B minus A. And the next one, B cube minus A cube. The next 1 minus 1, 0. The next subtraction, C minus B. The next one, C cube minus B cube. Now to continue, you should remember one formula. The formula is, what is the formula of A cube minus B cube? It is given by A minus B multiplied by A square plus AB plus B square. So just remember this formula. Okay. So that means we have a term of B cube minus A cube here, and we have a term of C cube minus B cube. Okay. Now see, to write this much of thing inside the determinant is a big thing. You have to write such a bigger one, right? So just remember the formula, don't show it inside the determinant. Clear? So you can observe that means the B minus A is present here, 0 multiplied by B minus A, and here also B minus A, and the expansion of this, right? Now that means B minus A is common from the second column, and C minus B is common from the third column. So what is that I should write? Taking B minus A common from C2 and C minus B common from C3. Clear? So after taking common, it is B minus A multiplied by C minus B. Now the remaining 1A cube. This is 0, 1. And now in place of this, B minus A is taken outside. What is the remaining? The remaining A square plus AB plus B square. Now the next one, 0, 1, C square plus CB plus B square. You have to just remember this formula, that's all students. Okay, so I have written even what is the thing which you have to take common from C2 and C3. Clear? So let's continue. We saw there were 3 ones, 2 ones were made as 0. It's been done. Okay, now the next thing is expand. Just 3 steps. Make 2 ones as 0, take common and expand. Right, now the rest is I'm going to go for the expansion of this. So I already have B minus A, I already have C minus B. The rest is expansion. The expansion is done only for this element. 1 second. Yeah, fine. The expansion is done only for the first element. So only for this, because these 2 elements are 0, no need to expand these 2. So for 1, product of these 2, C square plus CB plus B square minus left minus right. That is the procedure. Now the product of these 2, I will multiply minus sign directly for this. So minus A square minus AB minus B square. The next 2 no need to expand because the elements are already 0. What are the elements I can cancel? Minus B square plus B square will be cancelled. Now let us go for the remaining. B minus A multiplied by C minus B. Now let me group these 2 square terms, C square minus A square. I will arrange this. Okay, fine. The remaining element CB minus AB. Fine. Okay. So let us simplify it further now. Because my first element, what I required was A minus B, and here it is B minus A. I will take minus outside, A minus B. My next element should be B minus C, but I got C minus D, so take minus outside, B minus C, open the bracket. Now C square minus A square can be written as C minus A multiplied by C plus A, and from this B is taken common. The remaining element is the remaining element will be C minus A. That's fine, students? Okay. Now we have to just observe here what is common in these two. See, this is my first term, right? Plus my second term is B into C minus. The common in these two is C minus A, that is taken outside. At the same time, minus multiplied by minus will be plus. So A minus B multiplied by B minus C, C minus A is taken common now. What is the remaining element? Here it is C plus A, and here it is plus B. That is nothing but A plus B plus C. I hope we got the required result. The required result is A minus B multiplied by B minus C multiplied by C minus A multiplied by A plus B plus C. Not at all difficult, just 1 or 2 times of practice it's enough. Okay, you can understand this concept. What is the operation to apply? When to apply? What to apply? So how the subtraction is done directly? Which property is applied? I told you. See, this subtraction, simply it's not a subtraction, it is by using our property number 6. Then common, taking common, that is actually by using property number 4. Okay, fine, students. So 2 problems. In the 2 problems you have to notice one thing. 111 was given. Okay, that means it was present already, so we can start the procedure directly. So once you see 3 ones, 2 ones to be made as 0, 1 should be retained. Any one should be retained, 2 ones has to be made 0. Now to do that, you have to observe what are those ones actually, where are they present? Are they present in leading elements of rows? Are they present in leading elements of column? We need to observe. Clear? Okay. Now let's continue. So I will move on to the second column. It is given as x, y, z, x square, y square, z square, yz, zx, xy. Correct. And this should be given as x minus y multiplied by y minus z multiplied by z minus x multiplied by xy plus yz plus zx. We have to prove this. So let me erase the right hand side which is present. Okay, now I will start with this as my left hand side of the problem. So notice that we don't have 111 in any column or 111 in any row. It is not present. But if it's not present, we can sometimes make it. Yeah, okay. Now to do that, a simple procedure I'm going to do here. What I do here, okay, now just observe. Can I take x common from here? I can take common in this, okay, but x is not present here, x is missing. And if I want to take y common, from this y is missing. And if I want to take z common, from this z is missing. Correct? Now I will introduce the missing element. How to introduce the missing element? Multiply and divide r1, r2, r3 by x, y, z respectively. That's a procedure. The missing elements will be introduced. Clear? Now, division I will not show it inside. Right? Each element of R1 has to be divided by x, right? So the division I will write it outside. Of the first row, of the second row, of the third row. Only multiplication I will show it inside. Multiply each element by x. So this becomes x square, this becomes x cube, this becomes xyz. Correct? Now the next one, here it's going to be y square, y cube, xyz. Next, z square, z cube, xyz. Now notice something. Why the missing element was introduced? Just observe. This is C3, and in C3 xyz is common, that will be taken outside. And I already have 1 by xyz. Okay. And from C3 the common element is xyz. it will be kept outside the determinant by using property number 4. What are the remaining elements? X square, x cube, 1, am I left? Y square, y cube, 1, then z square, z cube, 1. If 1, 1, 1 is not present in a row or in a column, somehow we can try, not every problem, in some problem at least, somehow we can try to make it 1, 1, 1 and to start the procedure like the previous 2 problems. This is the procedure we have to remember. So that's a concept of introducing the missing element. Clear, students? Now look here, this time they are not the leading elements actually, okay, but this is an element of R1, that's an element of R2, and that's an element of R3. Fine? Okay. Now what I will do here, I will make these 2 elements as 0. So that means I will apply an operation for R2 as R2 minus R1, and for R3 minus R2. So notice x, y, z get cancels. So there is nothing outside the determinant now. So see, each element of R2 should be written as R2 element minus R1 element. So y square minus x square. First row no change, x square, x cube, 1. So this will be y square minus x square. The next y cube minus x cube. The next 1 minus 1 will be 0. The next one z square minus y square. Z square minus y square. Z cube minus y cube, and this element will be 0. That's fine, students? Okay. I need space, so let me erase this. Okay. So let's continue. And now observe. Once 2 ones are made as 0, what's the procedure? Taking common. What is common from R2? This y square minus x square can be written as what? Y minus z multiplied by, y minus x multiplied by y plus x, correct? At the same time, y cube minus x cube. Use the formula of a cube minus b cube. Y minus x multiplied by y square plus xy plus x square. Now that means y minus x is common. So that means from the second row, y minus x is common. Similarly, from the next row, z minus y is common. I will take out the common element and keep it outside. So the element which is already, I can just take out y minus x multiplied by z minus y. It's been taken. So x square, x cube, 1. The next one, in place of this, y plus x, because y minus x is taken outside. In place of this, y square plus xy plus x square. And here it's going to be just 0 as it is. And now z plus y, in place of this, z square plus zy plus y square, and the last element will be 0. Fine? Okay. Now the rest is I should go and multiply and expand everything to get the remaining elements now. Right? Now I can go for the expansion, or still if you want you can just simplify and then go. It's continue. It's not a problem. But let me go and expand it directly now. So what is the expansion will be now? Y minus x multiplied by z minus y multiplied by. Expansion should be done for what? If I want to expand for the first element, x square, it's going to be 0. And my next element, minus x cube, again it's going to be 0. That means the expansion should be done only for the last element. Clear? So only for this I have to multiply these 2 minus these 2. I will write here properly. Y minus x multiplied by z okay, fine. The first 2 elements will be 0, 1 multiplied by. Okay. So only for the last element I should show the expansion, right? So what is the expansion? Left diagonal. That is y plus x multiplied by z square plus zy plus y square minus z plus y multiplied by y square plus xy plus x square. A bit lengthier problem, okay, compared to the other. This is a bit lengthier one. Fine, okay. So let me start multiplying. Y minus x multiplied by z minus y. Now the thing, now I should multiply first with y and then with x. So it's going to be z square y. Next one, y should be multiplied. So z y square. The last one, y cube. Now let's multiply x z square plus x y z plus x y square. Multiplication is done, correct? Multiply these two, but each element should be multiplied by the minus sign. So it's going to be minus z y square minus z x y, and the next one minus z x square minus y cube minus x y square minus x square y. Maybe if I'm unable to get the answer, then something went wrong in this step. Okay, the other steps are absolutely fine. Okay, let us try to cancel. Z square y. Do we have z square y somewhere? plus z square y anywhere here? No, we don't find. Zy square. Let me cancel. And plus y cube minus y cube. Okay. The next xyz plus xyz minus xyz. Anything else I can cancel? Plus xy square minus xy square. I hope that's it. Let's write the remaining elements. Y minus x, z minus y, then z square y. Okay, fine. And the next element is what? The next element is plus x z square. Correct. And here minus z x square minus x square y. These are the remaining elements. So observe. So the first two elements will be as it is. What is common in these two? The common in these two will be z square. If I remove z square outside, what is the remaining element? Remaining element will be y plus x minus. What is the common element from these two? Minus x square. What is the remaining element? The remaining element will be z plus y. Okay, fine. I should check actually from this combination, am I going to get my required answer? Certainly not. Correct, right?